Okay, so hello everyone, and thank you for joining Mashav's online event, sharing Israeli know-how and innovation in honor of World Bee Day 2026. Please note that this event is being recorded, and the video will be available on Mashav MATC YouTube channel, so that you can watch it again and share it with your friends and colleagues. If you want to ask questions during the presentation, please use the chat button located on the toolbar, and our experts will try to answer all of the questions that they can at the end of the presentations, time allowing. So we have quite a full and interesting program ahead of us. And to open the event, I would like now to welcome Ambassador Einat Schlein, Head of Mashav, Israel's Agency for International Development Cooperation. Einat.
Thank you very much. So, good morning, good evening, good afternoon, wherever you are around the globe. I'm happy to see so many people joining us, just looking at the names from really all over around the world. So, I'm happy to welcome you on this sunny afternoon directly from Jerusalem. So, today we're gathered here to speak about the various innovation and various aspects of bee life. However, we're here really to honor the bees. And when we speak of bees, we can think of a lot of relevance to the bee world and the world of development, which we are all either working in or engaged with or interested in. That is, the bees are a part of the very unique and special ecosystem that we all depend on. And all of us are familiar with the disappearance of bees from certain areas and the infiltration of foreign insects to the territories of the bees, and the various kinds of bees which have been developed or skewed from the original nature due to interferences, mainly led by people. And what are we doing together in this regard, be it any ecosystem or the bees ecosystem? We're trying to preserve our world, to preserve nature, to preserve our environment, to continue and guard the variety of species around the world, whether we speak of animals and plants or any other ingredient of this very unique globe that we're all living in. And just like busy bees, we are in the development world, we're running around the world trying to do our job meticulously and at the same time provide a very important service and work together as partnerships, in partnerships, which really touches upon the most essential beacon in the beehive life, which I think is very applicable to everything that we do and we aspire to do together. This is all about group effort. It's all about partnerships. We believe in partnerships. When we speak of any issues, we always mention the fact that not only that we actively seek for partnerships, we believe in them, and partnerships will allow us to spread our wings further and further and get to new and much more comprehensive achievements. Just like the bees, they're all pulling in for one goal, which is to support the collective ecosystem of which they are a part. And this collective effort supports our environment, supports the plants, supports many processes which contribute significantly in their turn to everything that we do as humans. So it is definitely our duty and as well as our interest to preserve this unique species, which contributes so much to our world and also reminds us that cooperation and partnership are key beacons of our lives. And only if we preserve them, we can get, at least at the end of the day, to some sweet outcomes which we could all imagine ourselves. So thank you for your interest in this topic. Thank you for joining us. Mashav Israel is very engaged in the global community. We're trying to offer many webinars and lectures, as well as many training opportunities in Israel and abroad. So thank you for joining here today. Please, let's keep this relationship, keep in touch, continue coming to our activities, joining our activities online and offline. And I want to wish us and all the bees in the area, in all the countries, a very happy Bee Day. Thank you so much.
Thank you so much, Ambassador Schlein. And now, before we invite our speakers, I would like just to show you a very short film about Mashav. Thank you.
Mashav, Israel's Agency for International Development Cooperation, was launched in 1958 to share the know-how and technologies that provided the basis for Israel's own rapid development. We address challenges in a holistic and innovative way and support fellow nations and communities in their struggle to achieve sustainable development. Envisioned by the nation's founders to share Israel's knowledge and experience, Mashav aims to empower those living in poverty to improve their own lives. Placing people at the heart of its initiatives, Mashav focuses on capacity-building programs in Israel and around the globe. Our alumni return to their home countries and adapt the knowledge and skills they acquired for the benefit of their communities.
At Mashav's training centers, we focus on training professionals from around the world to harness innovative solutions for their communities. By focusing on peer learning and hands-on experience, we're building a network of global leaders equipped with Israel's unique expertise. We are proud to support real change makers and witness their invaluable impact at the local, national, and international level.
Our agricultural programs use unique techniques and farming methods developed in Israel to increase sustainability and quality in agricultural production, paving the way for food security and hunger eradication. We believe that investment in education is an investment in the future and an agent for change, and Mashav is committed to achieving quality education around the world. Mashav coordinates Israel's official humanitarian assistance, building medical facilities, and supplying medicine in the wake of earthquakes, floods, famine, and other disasters. Mashav promotes innovative entrepreneurship as a means of advancing growth and prosperity. We believe that gender equality and women's empowerment are central to achieving sustainable development. Our holistic approach to gender, poverty reduction, and sustainable development changes lives all around the world. Israel shares the global responsibility of striving to achieve worldwide sustainable development in line with the UN's 2030 Agenda for Sustainable Development, with a philosophy to leave no one behind. Over the decades, Mashav trained over 350,000 people from more than 140 countries and has established hundreds of centers of excellence worldwide.
As head of Mashav, I'm proud to lead our mission, investing in human capital, empowering individuals, assisting those in need, and working with diverse partners to support sustainable development. Since the late 1950s, we've trained over 350,000 people, built hundreds of centers of excellence, and delivered change alongside our strong alumni networks. Mashav is concentrating on capacity building, sharing Israel's unique expertise and creative innovations at the forefront of the global effort to confront climate change and build community resilience, committed to these sustainable development goals, partnering for a better world.
Okay, so now, without further ado, I would like to invite our first speaker, Dr. Victoria Soroker, honeybee researcher specializing in honeybee health, formerly from the Volcani Institute. The ARO is National Agricultural Research Organization, and she's going to talk about whether or not we have solved the honeybee problems ever since we have first heard about the colony collapse disorder. So, Vicky, Dr.
Yeah.
Soroka, the floor is yours.
Yes. Okay. Did I share my screen?
Wait, it's happened. Yes, we see it very clearly. Thank you. The floor is yours.
Thank you very much for inviting me. Actually, I'm very much believe in the goals of Mashav and had an honor to participate in some of its activities. So far, I also trained some people, some researchers from Ghana, Cameroon, and India. So some of what will be telling you today is actually a product of our collaboration till today. So just not to forget, I wish you the happy honeybee day, although I'm not going to talk about maybe all the very happy things regarding the honeybee, but we should all keep and wishing our honeybee the very, very best. So what I wanted to talk to you is what has really changed since we first heard about colony collapse disorder, and it happened about 19 years ago, almost 20, I would say. And I think that all of us heard about this situation that honeybees are disappearing mysteriously. And today we are not talking so much about the mysteriousness of the phenomena, but we are talking about more about colony collapse. Okay, we don't think it's something very mysterious. And in the coming minutes, I will try to show you probably the drivers behind it. I also have to mention that today, that these days, I'm not only emeritus of Volcani Institute and still active there, I'm also one of the executive members of COLOS, which is Honeybee Research Association, International Association, and and any researcher globally can join this organization for free and be a part of what we are doing and a part of what I'm gonna tell you today. So now I'm trying to move my next slide and it's not happening. I don't know why. Oh, here it is. Okay, so what is really the problem? The problem is not so much about honey that always, when you're speaking with people which are not familiar with honeybees, they will tell, oh, what is the bees are important for, and they will tell you the honey. But in fact, it's not the honey we are worried about. What we are worried about is completely another, I would say, major contribution of honeybees to our agroecosystem is the pollination services. We all know that the population, human population, is growing, continuously growing. And when it's continuously growing, the demand for food is growing. So it's a demand for high quality food. And it means that we need also to have a lot of land which will be devoted for this agriculture. And we can just think about what does it mean for the honeybee. We mean that we have intensive agriculture, usually monoculture with a lot of agrochemicals involved. But we still want the bee to be very active, very efficient, the colonies to be very strong and very big. And only this can provide us with great quality and a lot of food. But I think, that where the problems coming from because of those high expectations.
And so for the last 20 years, we are really what we became following this occasion of colony collapse. Suddenly people started to understand what are the bees are important for. What can be a consequences of collapse of honeybee colonies? And what is actually is the danger that it endangers food security. So we should see in B somebody not only inspiring cooperation, which is great and wonderful, but also its significance as securing our food security. And as it was before that we saw this in the internet and not on the internet journals that were talking about what is the world without honeybees, how terrible it will be, the colony collapse crisis are not stopping. Maybe this year it looks a little bit better, but just last year in United States, there were areas that experienced up to 70% of colony losses. And this is huge. And this is huge, not that it means that the number of colonies overall will get lower, but sustainability of beekeeping for the bee growers is really reduced. So it's the fact that it's not that we are counting the colonies, how many we can produce. It's how much at the end it will be cost and how beekeepers will be able to keep it sustainable. And here I would like to show you some pictures about it. So if I took the global honeybee colony loss map, I mean, and I can tell you it's not so easy to get to those numbers. And these numbers, I would say, although we put a lot of efforts in Colos Association, where we monitor 35 countries for colony losses, and we also do in collaboration with Africa. I will show you soon because I saw there is a lot of people from African countries that participating in our webinar. And a lot of people in North America are working about this issue. It's not so easy to estimate how many colonies are dying annually. But you can see that roughly, we can see that on average, over this period of these, I would say, almost 20 years that we started looking globally at honeybee colony losses. So we can see that they are going somewhere, I would say, from about 10% up to 45% on average. And we see here in red, the worst situation is in North America. But I'm not sure that this is so accurate because I know that in America they put a lot of effort on it. And much effort is made in other countries. And in Asia especially, we don't know. And the fact that we don't, I mean, the losses in Oceania, especially in Australia, are still very low, is again telling us something that actually in that area, they started monitoring losses quite recently. So if we are going to colony losses in sub-Saharan Africa, where my former postdoc, Beatriz Naganso, you can see her picture, and she's a great scientist that's working these days in Isipi in Kenya. She's doing a lot of great work. And there we conducted a huge research in which we looked at colony losses in 9 sub-Saharan African countries. And there were beekeepers, 1,786 beekeepers interviewed, which represented almost 42,000 colonies. And they showed losses ranges between 10 to 45%. But even if you will see this on this graph, and you see some countries are from East Africa, from West, from Central Africa, but you see even within the countries, there are differences. So if I'm telling you that one country like Uganda had over 45%, it doesn't mean that all Uganda has this. These particular areas in each country, there are variability. And we will discuss more what can be the reasons for those variabilities. when we ask specifically the beekeepers what were the drivers of these losses, you can see a lot of variations because you see, I put here in on the left, on the top left, you see here this is all together the split, the spy by split, and you can see that the major were issues behind beekeepers' control. What are those issues behind beekeepers' control, which are responsible for almost 30% of the losses? It's reduced foraging area, water availability, bushfires, and in some countries more, in the others, theft. Okay, theft, it's something that is, we cannot really try to avoid. I mean, we can try to avoid, but it's really behind, it's not within agriculture, Ministry of Agriculture, some other areas, agencies should take care of it. We can think about what we can do about other things. But you can see over, if we are looking at different countries, actually the causes or the risk factors effects are very different. In some countries, you see these absconding, for instance, is a very big issue. You can see that Nigeria, 45% is because of absconding. Absconding is the situation in which the bees just leaving the colonies. They're not staying. For the beekeepers, it's a loss. For ecosystem, maybe not. We don't really know what's going on. But overall, we should consider that in different countries, the beekeeping is really different. For African beekeepers, which usually depends, and cannot talk about all Africa, but in these countries that we worked in, we know that apiculture is based heavily on collections of free living swarms, which beekeepers keep they catch, and then they keep them in their colonies. And we also noticed that actually in some areas, the ability of beekeepers to catch those swarms decreased, which is very, very, I would say, concerning for the beekeeping community in Africa. If we're looking at different countries overall, and I'm talking about what are the local pest significance in the different countries, you can see that, I hope, I mean, I'm not talking to the people that completely don't know anything about bees, because this is really might be not comprehensive for them. But I will just to give you a little, just introduction, that bee colonies suffer. I mean, like, since it's a very high, I would say, nutritious source, a lot of pests and the pathogens attacking them. But these are quite different between different areas. So if we are talking, and here I listed the countries about which we have the information about, so you can see that in many countries, varroa mite, about which you're going to have a lecture by Dr. Nurit Eliash, and is in number one pest. But in some countries, there are completely some others. We have Nosema serrana, which is a fungi. We have pathogens like AFP, it's American foulbrood, and which are very important. But we see that, for instance, in sub-Saharan Africa, we have completely different pests, which they consider number one is the wax moth and the small hive beetle. But overall, if we are looking at countries besides Africa, I would say that varroa mite is the major pest of European honeybee almost worldwide. If we're talking about which pathogens or pests are associated with really severe colony losses, again, it's a bit different, but we can say that varroa destructor on the lowest one is almost worldwide. And I say almost worldwide because honeybees living in different parts of the world are different in their ability to manage this pest. For instance, in African bees, They are really equipped with innate mechanisms, which I will mention later on, which enable them to cope with the varroa mites. In the other areas, it's quite a disaster. We can see that in some countries, the viruses are really playing a very important role. And as I will mention later, viruses and varroa might have a very strong connection. There are bacteria like American foulbrood is also playing a big role quite worldwide, but now, I mean, in some countries, because it was really quite severely measures taking kind of eradicating the infected colonies. And in some colonies, they're using, some countries, they're allowed to use antibiotics. So this is probably, at the moment, I would not consider it the main cause of a major severe colony loss worldwide. And of course, we also have agrochemicals. Agrochemicals was a very big issue, and in European Union, many agrochemicals were banned, like neonicotinoids. In some countries, they were not banned, but a lot of efforts are made worldwide to try to somehow to limit their use if possible, or at least to limit their application to times and formulations where the bees would not be so much harmed. But the problem is that we are not, even if when sometimes we seems to us that we manage to save something, develop some methodologies to cope with some pests, we keep getting new pests. And the pests are moving, and pathogens are moving around all the time. And this is our, I would say, the major problem. We should start with varroa that we tried to be, I mentioned earlier as a very important pest, that it was really also invasive pest that invaded us from Asia, somewhere 70 years ago, maybe a little bit earlier. And now we still have not managed to cope with it successfully. We had Nosema serrana, the fungi that also came from Asia. We also now have Vespa volutina, which is another terrible wasp that spread from Asia and now spreading in Europe. I think it still not exists in Africa and not in the States and even not in Israel. But I mean, and this is a very big problem because these invasive organisms take advantage of the fact that bees are not adapted to them. And then it's very difficult to control them. We also have a small hive beetle that is a problem now already in America. And as I told you, it's a problem in Africa. And it is spreading also in Europe. Luckily, we didn't get it yet. And the last one, but completely not the least, is the Tropilelaps mercedesi, which is the mite, another mite, which is a very problematic one. It actually spread and keeps spreading. It initially was endemic to Asia, and before, I would say 1920, we did not really thought it can be found in Apis mellifera. It was found in a completely another bee, a wild honey bee, Apis dorsata, and another, it's a giant bee, and laboriosa, Apis laboriosa. These are huge bee colonies which live on trees and sometimes also on houses of the people living in Asia. But there, this pest is not called, it was not really a pest. It was just a mite that was living there. Nobody cared about it. But it managed to make really a shift. And somewhere between 1970 to 2020, it made a shift to Apis mellifera. And it made a shift to Apis mellifera and start spreading in Pakistan, Korea, South Korea, China. It also was spreading eastwards, but it actually managed to establish in Central Asia and Uzbekistan. And we are not even today that we know exactly, I will show you in a minute where we know where it is. As it was found in some areas in Russia in 22 and in 24 in Georgia. So that's, we will see where we know that they are today. You can see that they are today found in also in Kazakhstan. It's found in some areas in Kazakhstan. It is presumably found in Kyrgyzstan. It's found, as I showed you before, in Uzbekistan. We have no idea what happens in Turkmenistan, in Turkey. You can see that in area of Russia marked in red, you can see it's really moving towards west, and it's a bit about north. It was occasionally found in Tyumen, you see, quite in the middle of Russia, and it's really not an area we think it can establish, but it was found there, but apparently it did not manage to establish itself. But in these areas of Russia, southwestern Russia, they do exist and they are established. The mite lives very similarly to varroa. It breeds in capped brood of honeybees. It reproduces faster, and apparently most of the methods that were used against varroa are not very successful against it. And the topi is expecting to spread, really keep because we have a very problematic issue of detecting it. And that's what I wanted to show you here, that usually we have the same problem when we have invasive pest. When it is introduced, it's very difficult to detect it. In Russia, for instance, and this is a specific case, it was detected in Krasnodar area where about 40% of brood cells were already infested by Topilellops. And you can understand that, and this when the scientists detected it. Usually, I mean, this is really not something at this point that you can do. And I can tell you that beekeepers are fighting there since it was discovered, and it's still going on, and not much success of eradication this pest. And the problem is another problem, is the problem of, I would say, agencies that should prevent its spread. And usually agencies are not acting upon, just prophylactically. They usually require beekeepers' awareness, which usually happens much later. And in this case, I mean, when these pests are coming, and how are they coming? They're coming usually with mostly with human help, other by trucks that are bringing new colonies to the areas. And this is also very much driven by the colony losses. If beekeepers lose colonies, they need colonies, and then they buy them. And when they buy them in the areas where they have it. And if, like in this case, in Russia, they were bringing it from southern countries, like from Uzbekistan, which was infected. And now this year, beekeepers in Russia made a lot of efforts and the agencies to stop. And today, all the European agencies in America also are really paying a lot of attention to stop this invasion, because this is a really, very big problem. And I hope you can, all of you that are not familiar with this pest, I invite you to look at the different information in the internet and get more information, or you can also write me an email and I'll be happy to guide you. Okay, so if I summarize the bee predators and pests and pathogens you can see in this slide, there are many of them. There are lots of them. And I just marked some with, this, signs, which are really a very important ones. So you can see the mites and you can see the viruses, especially these two groups of viruses. But overall, we know today more than 20 different viruses in honeybees. We, of course, have, as I mentioned, bacteria, the hornets, the fungus, and here are the mites. Mites, the varroa, and the Tropilelaps. Tropilelaps is just 1 millimeter long, but the size is not really indicates that it's less significant than varroa. I would say if they're not significant in the same level, so probably Tropilelaps is even more important for us. And the one very important issue related to varroa that they and Tropilelaps both that they are transmitting viruses to honeybees. And this is a very, very big problem because viruses is difficult to see. And just to give you an information about some of viruses, very common viruses that I am showing you today. This is black queen cell virus that we are not really, it's very common today. And the fact that you see these countries that it was detected in 2020 marked in red, but you see a lot of black dots which can tell you that it's not that it's not there, it was just not reported. It means nothing in this, that these are safe areas. And I can tell you that in Africa, we did the research just last year, and I can tell you BQCV is quite abundant there as well. We see acute bee paralysis complex, which is also, you can see how widely spread it is. Israeli acute paralysis that was initially accused for being one of the drivers of colony collapse disorder is one of those viruses, and it's very much spread. We have deformed wing virus, which is symptomatically showing deformed wings. It's really a big complex. We already know about several variants of these viruses. And this is a suck brood virus, which is a virus which we see symptomatically in the brood. And I can assure you that what we see and what we know is just a tip of an iceberg, as I draw you here, because the way we analyze viruses is usually mainly molecular. And if we don't know the virus, it's very difficult for us to identify new viruses. Okay, and the other important issue is that many of them occur in asymptomatic form. It means that we don't have any symptoms. Only by really deep sequencing and looking for virus sequences, we can really find that there are some of the viruses. And viruses changing in the world. So I can show you here a picture from Robert Paxton articles. And that's variant DWVA went down over the years when the same virus, but another variant of B went up with the years. And one of the reasons probably is because it can reproduce within the varroa mite. Maybe it can also reproduce within Tropilelaps, we don't know. So all these pictures are very dynamic, and also there are recombinants between these viruses, and some of them may be more virulent, some may be less virulent, we don't really know. And some important factors about these viruses, we know that transmission routes of viruses are really variable, some going through varroa and some going from the mother bee to her eggs and to the brood, from the male to the queen during the mating season. So it's a very problematic issue. Often colonies are infected by more than one virus, so it's very difficult to know who is responsible for colony collapse. Viruses interact between each other. And they also interact with the bee physiology, with its immune system. So, and detection, as I told you, very complicated. And as I told you, many of them are symptomatic, but they can become symptomatic with something is happening, like some stress factors can really activate them. On the other hand, if you just find the virus in the bee and it doesn't show any symptoms, maybe it's nothing to worry about. And sometimes when we see a virus and we don't know if it's a virus caused the problem, or maybe it was a pesticide or something else. But the good news that over these years, we found the honeybees have natural mechanism to cope with pests and pathogens, and they have many of them. I just want to start with something simple. Bees collect and produce antiseptic compounds like propolis that also humans use in medicine. Honey that bees store, also many of the honeys have antibacterial properties. Wax by itself can sieve out some of the poisonous compounds. They have social immunity system in terms of behavior. They have hygienic behavior by which they can detect and remove parasites and sick individuals before the disease is developing. And it can also suppress parasite reproduction, because if they remove the parasite before it's really started producing too much brood, so they can remove it. They do grooming. They can remove mites from one another. So these are very important social mechanisms. They also have, that I briefly mentioned it before, individual immunity. It's all kind of immune system. It's a different immune system from what we know, but they have antipathogen pathways. And here I brought you like 6 pathways from the literature, but there are more. They can encapsulate bacteria and they can suppress virus and microbial replication. So there are really more. So these is, I would say, a ground on which we should work more. So if I'm just going to summarize the main factors affecting bee health, and I would say what causes bees finally to collapse, it's when diseases are occurring. And we can see that a lot of things can affect. Of course, the tendency of the bee to develop something, just like with us humans or any other organism, genetics is very important. We know, as I told you, in Africa, there are bees which genetically have ability to cope with varroamide. And there are other possibilities in other places, maybe, and we know that if we are looking them, we can find colonies that have these abilities. So, but all of those, the bees' abilities, bee needs, as I told you, immune system, strong immune system. It depends on the on its, I would say, on nutrition, on strengths of the bee. The strengths of the bee is depending on the nutrition. Good nutrition that is often compromised by pesticides and also by climatic factors, like climate changes, bringing drought or bringing even floods. When it compromises the food source of the bee, its strength, its immunity is compromised. So here's, and I didn't mention it much in the Africa, but in Africa, when we saw the problem is bushfires, which are driven many times by climate, but also by human activities. But first of all, they limit the food of a source of the bee. The availability of good water sources, what we know is also another problem. So, as I finished, I just to present you with all the things that we learned over these, I would say, quite intensive 20 years, I would like to present you with take-home message. So, as I showed you, the apiculture faces a complex matrix of identify and continuously emerging risk factors, as you could see. There is really no silver bullet for solutions of any of those. The need for management is really high. Modern apiculture cannot remain sustainable without active knowledge-based intervention. It's not one pesticide, we give one drug, one antibiotics. We know today there is a lot of resistance, antimicrobial resistance against American foulbrood in America, and they advertised not to use antibiotics anymore because it doesn't help. We have a problem with varroa resistance, and one of the reasons for high honeybee losses in the United States is assumed to be varroa resistance to pesticides. So innate resilience. Honeybees, as I showed you, possess sophisticated innate biological mechanisms to cope with many of these stressors. We just have to know how to use it. New diagnostic and management tools are emerging, and I hope you will hear with speakers from our Israeli companies that are working hard to assist beekeepers in safeguarding colony health. We need, as I heard was mentioned by director of the Mashav, we need global approach. We need unified global effort to protect agriculture. I mean, by protecting our honeybees, and this will preserve agriculture and biodiversity. So we should all act together for balancing the bees' innate resilience with innovative management, as sustaining our bees means security of our global future. And it requires a unified effort from all of us. With this, I would like to thank you for listening to me. And if you have any questions, I'll be glad to answer. Happy Bee Day.
So thank you so much, Dr. Victoria Soroker. We don't have time for questions right now. We ask you to please present your questions on the chat. And after the presentation of Dr. Nurit Eliash, we will try to combine the questions, see if anything has not been answered, and then we will try, time allowing, to answer at least some of them. Okay, and I have put on the chat the contact information for Dr. Victoria Soroka, as she has invited you to contact her if you have any further questions and issues or would like some more information or consultation. So thank you so much. And now I would like to introduce you our next speaker, Dr. Nurit Eliash. She is also a honeybee health researcher from the Shamir Research Institute. And Nurit Eliash, the floor is yours.
Thank you, Tammy. Can you see my screen? Yay.
And I hear you very clearly. Go on.
Oh, perfect. Okay, so I just want to see I'm on time. So we're not on time, but till when do I have so I will know not to push it?
Okay.
I got it.
So since we started with a 10-minute delay. So now if you can, you have actually 20 minutes. If you can do that in 20 minutes, it would be really fantastic, and we will say thank you to you.
Yay, yes, I can do that.
Okay, great.
Okay, can you see my can you see
Yes,
my arrow?
Yes, we see the pointer as well. Yeah.
Oh, perfect. Okay. So first of all, thank you so much, Vicky, for this very good background. I will not talk about the importance of bees or anything of that sort. I will talk only about varroa mite, which is the only thing I know. And so I'm a disclosure. I was a PhD and a master's student at Vicky's lab. So I have a very good basic knowledge of honeybees and varroa mite. And in the past, and then I did a postdoc in Japan for 3 years. I came back 3 years ago, and since then, I'm a researcher at Shamir Research Institute, which is an R&D of the Ministry of Science and Technology here in Israel. And happy bee day. Okay, so this is the varroa mite, once again, on a honeybee. And let's dive in. That's a very, very close look. I want you to say hello and meet Varroa distractor. Her name suits her very well because it is very destructive. So it's a parasitic mite of honeybees. And when I say honeybees, I mean Apis, mainly Apis mellifera is where she does most of her damage today. But originally, it is a parasitic mite of Apis cerana, the eastern honeybee. And I will talk more about that. It explains a lot why we are really experience such damage from this mite. So this is a very close look. Here you can see how the mite is relative to the honeybee size. And if you want to have some kind of relation, you can imagine having some kind of a cat or very small dog on your shoulder, hanging all day, sucking your blood, very, very inconvenient and very destructive. So how does the varroa mite damages the honeybees? So we know there's a few direct and indirect damages, but first of all, it weakens the honeybee immune system and making it more vulnerable to other culprits. And it vectors highly virulent viruses, as Vicky mentioned. And this too makes the varroa mite the main cause for colony death worldwide. I think if beekeepers need to have one thing on their mind, this is the varroa mite. There's no such thing as a managed honeybee colony that is productive and commercial that doesn't have varroa mite today. And I will explain a bit more later. So varroa mite contribution to global colony losses is vast. And last winter in the US, we have experienced 55% colony losses, which mostly contributed to varroa mite and specifically to her ability to grow resistant to pesticides, which is a very, very big problem in agriculture, in any agricultural system, but in honeybees, as you can see, it is a very, very problematic problem. If you can imagine you're a beekeeper and you put 40 hives in your yard and you come back a few months later, you collect only 20. And the rest of the 20 colonies that are partially alive are partially alive because they are still experiencing high damage from the viruses and the mite. Here you can see a honeybee. You can see the difference between this honeybee, which has deformed wings, and this honeybee, which looks healthy. As you can imagine, this honeybee cannot fly, cannot pollinate, cannot collect any pollen or honey. But if I see this kind of honeybee in a hive, I'm pretty sure that all the rest of the honeybees are also experiencing high viral load. They are not, and also experience some damage in learning, in flying, and behavior. So the main problem with varroa, it is that it's a vector for deadly viruses. Tammy, can you look in the chat? I want to ask something very, very, very short, and people please reply fast and very short. How many viruses do you think honeybee has? And then we can talk about 20. Oh, Oren, Yofi Oren. 21. These are inside information. Okay. So we know about 25 viruses are known, which is a lot for an arthropod, for an insect. But how many of them can we find in varroa mite? So about 18. It's a lot. So not all of them are virulent. Only a few of them have been proven to be virulent, but that's a lot. Okay, it means it's a real vector. And these are only 3 of the known and very severe viruses. You can see the symptoms are horrible and the hive is collapsing when we have them. But how long before a colony collapse? 1 month, 2 months, 1 year. I don't see. Okay, so an untreated colony that I would do nothing to reduce mite population will collapse between 1 or 2 years. This doesn't sound so horrible, but as I mentioned before, way before the mite will die and you will have no living bees, the hive will be so dreadfully damaged from the viruses that it will be not functional. And we need a functional hive in order to pollinate our crops. And the hives is not functional after a few months or a year. So even if it's not dead, we have nothing, I mean, we can do nothing with this hive. So Varroa is a global pest. And you can see in here from the 1st of the century until today, we have Varroa mite everywhere. Australia is not up to date. A few years ago, it also penetrated Australia. And they were so panicked, they burnt down hives when they saw the mite is there. So you can understand the catastrophe. And I understand their panic. But what exactly happened? So I told you earlier that the Varroa mite is actually infesting originally the eastern honeybee. And this is here in Papua New Guinea. But what happened is human, mostly. Usually when bad things happens, people are involved. So the western honeybee is the most, is the honeybee that we use most for agricultural pollination worldwide today. And what happened is that people moved colonies of honeybees of the western honeybee for pollination and for honey production because they're so easy to manage. And the mite took this opportunity and jumped from the eastern to the western honeybee. It's not an easy jump, but she did it. And what happened is that while in the eastern honeybee, the Varroa mite is maintained in low population, the western honeybee has not co-evolved with the mite and she doesn't know how to deal with it. And the mite population grows. When the mite population increases, the virus level increase. And then the colony collapse. And then we see these symptoms in the hive. If I see these symptoms in my hive, I know it's too late. It's too late even to use pesticides because the hive is doomed. So what I learned while investigating bees and mites and organisms in general is when I want to understand how to manage a mite or a pest, I need to understand it. I need to live with it. I need to think like this pest. So I usually, where she go? Okay. So I observe. And this, as I explained before, because the mite and the honeybee are so well co-evolved, we really need to dig in to understand how to deal with it. So we have a perfect synchronization between the bee and the mite. And you can see in here a mite, she's pointing her 2 front legs and she's sensing the air, she's sensing the bee. And she can sense specifically chemical stimuli and volatiles that come from the bee. And she can distinguish between different bees and select her preferred host. We have another problem is that the Varroa mite has a stage in which she hides and reproduces inside the pupa cell, where she hides from our ability to expose her to pesticides. When she emerges, she can spread inside the hive while hanging around on a nurse bee and reproduce again. But although she's not movable and cannot fly, she can still fly between hives because she can hitchhike a forager bee, and a forager bee moves between hives. So she can also spread within the hive and spread between hives. And then infest many hives. And if we don't treat what you can see in here, it's the honeybee population when it grows. And just in a lag after honeybee population grows, the mite population grows as well. And if we don't treat, the viruses will grow up, the honeybee will go down, and the mite will take over the hive. So how we do cope with the mite? Because we do still grow bees, right? So we have a direct management, mainly, I would say, I would put only this option. I put the other two because I want to stay positive and I want to show you what we do a bit in our research. But mainly today, beekeepers use hard synthetic chemicals, okay? We can also do some indirect management by strengthening colonies, put supplements of food, or do genetic breeding, which is a very important issue, but I will not talk about today. But mainly we put a very hard pesticides in the hive. And I can live with hard chemicals. We do that in most agricultural crops. It's easy to use. I understand that. It's cheap, fairly cheap, and it's efficient. I put a question mark in here because it's harmful to the bees and to humans, of course. It resides in honey and wax. And the most important problem, it evokes resistance. And once resistance grows, it's no longer efficient, and we cannot use hard chemicals. So what we can do, and what are additional challenges in mite control? I want to show you how hard system it is. So first of all, we said we had a perfect host parasite synchronization. It's very hard to disentangle between the two. In addition, they are related. Think about it. The honeybee and the mite, both are arthropods, okay? So all of the pesticides that we use against the mite also harm the honeybees, which is, if you think about it, is very, very different from any other agricultural crop. For example, if you have mites or a moth in a plantation, we protect the tree by eradicating the pest, and they are not related. So this is a very, very problematic issue. The hive is a very crowded habitat, and it's another problem. They have the hiding stage that I showed you before, so they are half of their life not exposed to any pesticides we put inside the hive. And in cases where we have brood year round, in places where climate is very easy, and you don't have a very cold winter or a very hot summer, so she can reproduce all year round until the hive collapse. In addition, in many countries, in Israel specifically, we have very high hive density, and I showed you before the mite can transfer between hives. So all of this makes mite control almost impossible, but I see here also an opportunity. So what we do in research, we study this interaction, tripartite interaction between the honeybee that we wish to protect, the parasite that vector viruses, for sustainable varroa management. We wish to understand the varroa bee virus interaction and to study varroa resistance to pesticide, which is some of the things that I do in my lab. I will give 2 examples about how we develop sustainable tools for varroa management, and they both relate to what industry researchers will talk to you after my talk. About bee and environmentally friendly pesticides that we develop, and agricultural method as well. So developing friendly pesticides for bee and environment, which is something I do in collaboration with 2 bee company. Avner will talk after that. And we are looking for specific varroicides that are not harming for the bee, because all the pesticides we have so far are both harming the honeybees. So we need to look for specific pesticides and to apply them automatically inside the hive. So this is exactly what 2B does, and Avner will talk about it a bit more. But this is the main thing that we are aiming to find varroa-specific pesticides. And what we do in my lab, which is another challenge, is to grow the mite inside the lab on honeybees in capsules. We look at survival, reproduction, and feeding behavior, and we see that we can find some substances that don't harm the bee and have some specific change in behavior of the mite, which can cause her death. Some agrotechnical tools. So as Vicky mentioned, and maybe if you keep bees or you're in contact with bee colonies wherever you are, maybe you have found that sometimes the honeybees abscond or swarm. They leave the hive. When they leave the hive, there is a time when you have no brood. And as I mentioned before, the varroa mite is reproducing inside the brood cell. So if she doesn't have a brood cell to enter, she's exposed and she cannot reproduce. So all we do is imitating the natural host. We do a queen cage. Then we have a time we have no brood, nor producing mites, and all mites are outside. And when there's no brood, we release the queen, and we can apply some soft pesticides that are not very harmful and remove all the mites. So this is another thing we're promoting. I want to mention again what Vicky said about the new pest, which is really, it's a nightmare. Here you can see the varroa mite, it's on a larva of a bee. And here you can see the new mite, Tropilalaps. She's much more vivid, she's fast. And yeah, that's our main concern at the moment. So if you see anything like that, please report. So the future of bee mite not control management, as I see it. Today, we're using only chemical pesticides, but the way we should be going is to develop soft and green pesticide, use agrotechnical tools, as I showed you before, and promote genetic breeding and nutrition. And for that, we need a collaboration between these four circles. I'm here, but any of the other collaborators, only if we work together, we can accomplish the management of varroa mite. That's it.
Thank you so much, Dr. Ilyach. That was really very, very interesting. And it was a really great, it's great now for us to make the transition to the Israeli startups and companies who are going to introduce to us their activities and some innovations that are very interesting for assisting not only the bee health, but the monitoring and the pollination and all of the other aspects. So, but before we go to the Israeli companies, I would just like to point out all of the huge diversity of participants that we have here. And you are all welcome to also put on the chat now. We see that we have our friends from Ghana and from Kenya, from El Salvador, from Guatemala, from Rwanda, from India, from Brazil, from Myanmar, Zambia, Malawi, Ethiopia, Nepal, Liberia, of course, from Israel, some speakers and some participants. Did I forget anyone? Let me know on the chat. Let me go down and see if I forgot any countries. Okay, so welcome to you all. So happy to see you. And it's also very, very nice to see, maybe not all of the faces, but a lot of the Mashav alumni who are here present. Welcome. It's so nice to see you all. Okay, let's continue our wonderful event. And now I would like to invite our next speaker, who is Mr. Avner Einav from To and he is going to introduce to us the To innovation, which is the Hive Master, and tell us a little bit about what To does. So, Avner, the floor is yours.
Hello, Tammy. Thank you so much for inviting me. It's a real pleasure being here and so exciting seeing so many people around the world. Oh my God, it's an amazing activity and happy B-Day for everyone. My name is Avner Einav. I'm representing To and I want to speak about the hive health in general. You know, it will come as a continuance to both of Nurit talk and without further ado, so in a couple of words about us, about To so we are a company of beekeepers. Both of the founders are beekeepers. Most of the people working in the company are beekeepers. And the thing that's interesting us the most is helping beekeepers and making this amazing agriculture and hobby and a huge part of mankind existence, something that is possible and vivid and even fun. So this is what boosting us forward. I'm the VP product in the company. I'm an engineer and also a beekeeper myself. So I will really go quickly because we've been spoke about this before, but I would say that we know that 1/3 of our food dependent on honeybees. And if we'll kind of move this towards to financial impact, it's somewhere around 250 billion in pollination products around the world. So this is a huge number, and we know that there is a huge risks, okay? And we know in the last 30 years, 20 years, we see declining in the percentage of hive losses every year. We know it's been a terrible year in North America. Some people lost 60 and 70% of their hives. And of course, they cannot recuperate after this kind of, catastrophic loss of hives. Okay, and this, it can just keep on chasing us every year. And there are many different theories why we're losing the bees, why it has become so hard to grow bees. And for me and for us, there is only one main reason, and that's the varroa mite. And I mean, if you go and speak with a beekeeper that have a lot of experience, he will say, "Oh, 30 years ago, it's been easy. Yeah, I was just, throwing on the honey supers, collecting the honey, and that's it. Swarming, that was my biggest problem. And even now, if I had the privilege to visit in Australia, and that's the way it was in Australia in 2 years. They didn't have the mite. They were collecting 80, 90, 110 kilos of honey per colony, easy as that. The biggest problem is swarming. And the varroa mite, even if you cannot see the varroa mite, it's weakening the colonies, weakening the bees, and then different elements overcome. It could be the climate, it could be the forage, it can be the different viruses, it could be many different reasons. But at the end of the day, when the bees are weakened by the varroa mite, that's the result. And of course, there is the Tropicalaps, which kind of, it's out there, coming towards Israel, towards the rest of the world. So we need to be prepared. And for me, I worked in an agrotech company, and it's a bee tech, and for me, it's a mysterious way. How come there are millions over millions of dollars invested in innovation, but we see this graph of percentage of losing colonies, and every year it's only getting worse. We don't see the innovation changing for the best. We see the problem only getting worse. And I'm trying to scratch my head and think, how come we don't have an impact, positive impact on the industry? So, this is my 2 cents. I hope you will agree, and if not, you're welcome to kind of write on your
Oh, yeah,
comments.
definitely. Right.
But definitely one of the biggest challenges is the biology part. You treat for the mites, you damage the bees, the same miticides, they affect both. Okay. From the other hand, you undertreat, they might damage the bees. And then if you want to go and develop a medicine for mites, that can take 5 years, 10 years, 15 years, cost millions of dollars. So we haven't seen new medicine for years in the industry that is approachable. Okay. And now you go to the world of sensors, weights, different ways to use technology to get information. And then you just go and look at the profitability of beekeepers around the world. Their margin are so low, they're having a very hard time to invest and change the way they work. So this market does not, you don't see many companies that actually changing and widespread. You compare this industry to poetry, you can't see a poetry place without sensors, agriculture, soil humidity. In the beekeeping industry, most of the beekeepers still using wooden box. They go out there every 2 weeks and they work to do the stuff. So this challenger we want to overcome, and this is how we come with the hive master, which is harnessing technology, harnessing sensors to do stuff that helping beekeepers, not only provide data, do an active change in the industry. You can see right here, this picture we took this picture in northern Israel in the Galil. It's one of the biggest beekeeper. It's the biggest beekeeper in Israel that he worked with us, Zohar, from Dan Apiary. And he's holding our device. This is the device we've developed. This is a durable device. This is a not expensive device that installed in any hive, compatible with any type of gear around the world. This device is automating the treatment for varroa mites, collecting data, transmitting them back to the beekeeper, and is there to help beekeepers to earn more money, and changing the reality as we know it right now. And how does it work? Okay, so we come to the conclusion instead of developing a very complicated, very expensive chemical through the regulatory path, waiting for years, we want to giving the people the tool to treat their hives with off-the-shelf substance. So beekeeper can take natural medicines like oxalic acid, formic acid, thymol, many other substances, mix them with liquid, insert the liquid inside the device, insert the device inside the hive, program the device, and then the device will automatically treat the hive in the optimal time. Adjust the treatment to the strength of the colony, adjust the treatment to the environmental condition, and can treat the hive for 6 months without interference of the beekeeper. Okay? So, as Nurit explained, most of the industry dependent on synthetic treatments being loaded on pieces of rags, like in the United States, or strips like in Europe. You insert those strips inside the hive, and then you flood the hive with chemicals. The bees will carry on their body the chemicals for 6 weeks. Hopefully, the mites will touch the chemicals and die. Unfortunately, when you introduce a hive for 6 to 8 weeks in very harsh chemicals, you are damaging the bees, you're encouraging the buildup of resistance of the mites, okay? And you waste time on labor. And that's a problem. And this is why we're losing chemical, we're losing time, we're losing the productive of the hives. Our method is completely different. We install the device inside the hive, and then we use a micro pulses of gas. Okay, so our device spread a very soft fog inside the hive, treating the phoretic mites. As Nurit explained, this is the mites that is outside on the bees, and dropping them down. The bees has the amazing ability to clear the chemicals out of the hive in a couple of minutes. So it's an automated, very intensive, but very short. So we're damaging the mites, but we don't damage the bees by a long exposure to the chemicals. Okay? So at the end of the day, we use somewhere around 90% less chemicals compared to the alternative. For us, we look at the apiary as a fleet. So, if you're commercial beekeepers, you got a lot of hives, they're spread around. Today you need to go evaluate the size of the hive, the infestation level, how much you should treat, how many repeats you should do. So our system is doing that for you. You program remotely by the app. The app communicate with the properties. It can be hundreds or thousands or just couple, it doesn't matter. We will use sensors to evaluate the hive. We use AI to adjust the best treatment, and then we do the micro pulses of gas, automatically treat the hives for you, and then we just letting you know that everything is okay, and you can continue do your job as a beekeeper. And as I mentioned earlier, so we're using available natural substance that anyone can get, but we also work together with Nurit Eliash, screening hundreds of different natural materials that can help knocking down the varroa mite without damaging the bees. And we have a few promising ones, and we hope we'll have good news about that in the near future. I would like to share a bit about the results we have. So this is one experiment we done in Florida, at the USA, together with University of Florida and one of the biggest beekeepers over there. So we took a big bunch of bees that was highly infested by varroa mites. Half of them, they've got our Hive Master treatment. The other half just got the off-the-shelf standard varroa treatment with strips. After 15 days, we have knocked down somewhere around 95% of the mites, and in the control group, there has been only 14% efficacy. But that's not the big news for me at least. The big news was the standard deviation. Look how stable was our treatment compared to the conventional. So it's not only being super effective, it's about being persistent. Because if some of your colonies are still have high infestation, you will lose them. So this is a huge benefit. We even opened some of the cap brood, the pupa, and we just spilled over the larva of the bees to count what's going on inside the hive. And we've seen this result was very similar inside the bee pupa. So it's an amazing result. Another result that I would like to share with you real quick, it's an experiment we've done in Thailand with a local research institute. So as all of us really in a scare about the tropical lapse, we wanted to see the effect of our technology about this very hard to treat mite, because this mite is 90% of 95% of the time, maybe even 99% of the time inside the cap brood. So we went there, we done our treatment, we've tested the hives. It's a very preliminary result, but we have got over 90% efficacy in a queen right, full with brood hive, and it's a huge result that I'm very pleased to share with you. At the end of the day, I mean, we are here to help beekeepers, and the helping of beekeepers is helping them to be to be able to exist, to earn, to provide services. So in a huge experiment we've done in Israel with thousands of hives, we've demonstrated 50% reduction in losses. That means that if the average beekeeper in Israel will lose 40% of his hive, using our methodology, he will lose only 20% of hive. And this additional 20% of hives, it's a huge difference. It's additional hives working for you, making honey for you, pollinating for you, and there's a huge benefit in that. But that's not the only thing. The other is that we've seen the rest of the hives was significantly stronger, and we've seen a 13% increase in yields. So, and maybe 13, it's not that crazy. You could say it's another frame and a half or 2 frames of honey. But if you multiply additional 20% of bees and additional 2 frames of honey, so that's a big difference in your ability to exist as a business. It's dependent on the market, but we evaluate the donation after the cost of our technology in additional $50 a year per hive. So we think it's a huge donation. Anyway, I was really exciting speaking with you guys. If you have any questions, please feel free. I would say that we are now moving towards commercialization of our technology, and we are looking strategic partners that can support and help us to introduce our product in different markets. So if you have any ideas, don't hesitate to reach out. You can scan this barcode, and thanks again for for listening.
Thank you, Avner. Thank you so much. It's amazing technology, and wish you a lot of luck, especially
Thank you.
in penetrating all of the markets here. I'd like to add some of the countries that I didn't mention earlier, but we have Uganda and Honduras and Senegal and Bangladesh. We have Italy, one of our speakers, Uzbekistan, Burma, Brazil, Ukraine, and Taiwan. So if there are any other ones that I forgot, still put it on the chat. And now we will go to our next speaker. We have another company called BeeWise, and it's precision beekeeping, something that is just amazing. It'll blow your mind. So I'm passing the floor to Dr. Raya Stelzer, also a bee researcher from BeeWise. Raya, the floor is yours.
Hi, could you see my screen?
Yes, we see it. Hold on. But right now it's blank. We saw it a minute ago. No, wait. We're not seeing it well.
No, you're not seeing it? Actually, wait a second. Again. Okay.
Okay, yes, we see it. It's great. You
So,
can.
Tammy, first of all, thank you very much for inviting me. I'm very excited. I love to be on these kind of things, especially if the workshop that we used to have here, it was a great pleasure, and face to face, it's even better. So now is also very exciting, especially with this company that I'm working now with BeWise. I'm working in the BeWise, and soon I would present our company, but I'm from the research department, so I'm not really gonna go with you step by step through our machinery as good as Avner did. I'm just gonna go straight to the research and how we approach it. That would be more similar to Nurit's talk, and I think it would be a very nice closure to, not closure because we're continuing, but some kind of a overview that summarize nicely a lot of the things that we've talked about today. So I think Vicky gave a very good introduction to this part. We know that honeybees are very important for humans in general, and we know that there's a huge colony loss, and Vicky gave a very good explanation what are the reasoning and how complex this situation is worldwide. And as a part of this, as we discussed before, the loss of habitats, the pesticides, climate change, and diseases that I think we all talked about it today. In the States, we also have traveling that is very intense on the bees. And of course, human labor. It's not easy to be a beekeeper, and especially if you run a huge business, it's even harder to find workers. So beekeeping is challenging these days. So BeeWise is a company that started in 2018 by 5 founders. And soon I'm going to go with you through the details of our machinery, but we're pretty big company right now. We have a huge operation in the States, but here in Israel, we have a nice part of the R&D, research and development. So there's plenty of engineers here. And in this R&D, we have a very small and efficient, maybe not so small, research department. And that's where I come along. By the way, I'm a biologist. I did my PhD at Vicky's lab together with Nurit, and so we're all a big happy family here that's talking to you today. So our bee home right now, this is the bee home that we work with in the States. The first thing that you should know that the bee home has a solar panel, so we could do many things robotically. We could do many things that communicate, send us that data. We have our robotic system manipulating the bees, the colonies and the bees. This is the robot that comes to the colony, picks up a frame. We could look at the frame, we could monitor it and get a lot of information. You're going to see parts of it soon. And the habitat itself, it's very well built. So it's isolated, and you could see the different color patterns in the column in the entrance. So it's good for drifting. So we build this machinery specifically for bees, and what we're trying to show you here that we have a beekeeper with the bees all the time. This is what our robot is doing. So our system, I'm not going to go into the details. As I said, I'm going to try to show you a specific story. So we do monitoring. We could do monitoring by visual, and we also monitor the temperature of the hive by IR scanning without opening the hives. And we could do actual beekeeping. We could do balancing. We could do feeding. Lately, we've been starting to work on splitting. And of course, if there's something we cannot do or something extreme happening, we could also alert the beekeeper. But in today's subject, as everybody here mentioned, we're going to talk about a harder case, and the case of Baroa. Also, Tropilela is going to come in, and how we, with our smart machinery, how are we trying to deal with the Baroa mite? And I'm going to go here slightly into the biology. I'm sure all beekeepers here know the story very well, but I do want to take a key message that Nurit said in her lecture. She showed a very nice picture of Varroa developing in the brood, and she said the word hiding. Varroa is hiding in the brood, and that's what we're taking here as an advantage. We don't look at it as Varroa hiding, we look at it as a trap. Okay, so now I'm going to go slightly into the biology of the mite and how we look at the sealed brood as a potential of treating the Varroa mite. So I think Nurit said it, and Avner has also directed his talk to the phoretic mites, the ones that are seated on the adult bees. They're spending a bit of time there, probably a few days, but then they go into the cells. They go into the cells and then they reproduce. This is the sexual time of their life. As Nurit said, they're hiding. Why are they hiding? Because most treatment are not going into the cells. These are this phenomena is usually where the mites are safe. They're not hurt by any pesticides. And after they're finished their sexual life, of course, they're going out of the cells, and they're probably each mother mite has 2 of her offsprings, and maybe this mother mite could produce at least 1, 2, and Nurit once told me that she also has the potential to do it 5 times. So this could be a very exponential growth of the mite happening in the sealed brood. Now, what's interesting about the perfect lineup that I think Nurit did it the best. I'm just a big fan of Nurit, yes. So Nurit explained how synchronized the lifespan of the mites and the bees are, but there is a slight difference. If we look at the tolerance to heat, we know that bees are more tolerant to heat than the mites. That's because the European honeybee heats the nest up to 35 degrees, and the mite, which developed in Naran apis mellifera, she does not have the tolerance to such heat. So this slightly different in temperature is what we're trying to find to use as a treatment here. And we didn't invent this, of course. There's many articles about treating the hive with heat against mites. And we just followed these articles, and also followed some mainly backyard beekeeping, trying to find solutions for that. So here you see an example of somebody trying to develop a machinery that heats the whole hive, hurting mainly the phoretic mites, trying to heat up the sealed brood as well. This is another technique of heating the comb itself. And we also know that there's there used to be an incubator that you could take to the field and try to heat, fill it up with 10 or 15 frames, heat it up, and then take it back to the hive. Very all of these never really got into the market, and they never got, definitely not into a commercial beekeeping. But as I described before, we have a different kind of machine. We have this, regardless to what I'm telling you, we have this robot that could go to a frame, scan a frame, know the context of the frame, and make a decision on that frame. All we need now is a place, a heat chamber that could heat the frame above the temperature that the mites are not able to continue living, but below the temperature that would hurt the bees. So as I told you before, we have this ability of screening frames and knowing if this frame is a sealed brood frame, as you could see here, and we could do it on all the hives in the robot. So we have autonomous frame level robotics. So with all of this potential, we went to our research, which I want to go with you through with you today. So we wanted to look at it, develop this potential, and see if we could make it finally give a frame level beekeeping in a scale, in something that beekeepers could use. I think, Avner, you said it the best. You said that we have so much research, but the problem is just going worse and worse because the research never gets back to the field. So this is exactly what we're trying to do here. So the first thing to do is find the right protocol. We want to know the duration. We want to know the temperature, that the specific temperature that would be, first of all, effective to the varroa mites, right? We want it to be as deadly as possible. So here's Paz, another very good student of Vicky Soroker. Vicky is the mother queen of all the research, bee research in Israel. Yeah. So he's also a student of Vicky. And here he's testing the sealed brood frames that was treated. And he looks at the mites and see who's dead, who's alive, and doing the percentage, right? So we're heating up the frames slowly until we get to the place that it's good enough to be very efficient against mites. We're looking for something that kills around 80 to 90% of the mites. The other end of it to be safe for bees. So we had some frames that we wanted to see that emerge as normal as could be, nicely emerge as you see here. And of course, we wanted to check the longevity of the bees. So we took the bees that were treated, of course, with the control group, we marked them, and then we put them back into the colony and see how long they lived. So after this very long process, I think it took us about 6 months just to get to the number that now we're using. We're heating up frames to 90 minutes in 43 degrees, and that's good enough to kill the mites and safe enough for the bees. Now, this is very nice. This is a frame level story, but now we also developed a protocol that works in the level of the hive, right? So as mentioned before, mites could be either in the brood or on the bees. So treating only the mites in the brood, that's just a temporary success, right? We want to have a very strong effect on the colony. So what we did is a two-step protocol. So in the first step, we treat all the sealed brood in the hive, right? That looks like that. We take all, as I showed you before, we scan the frames, we put them in the heat chamber, and then we put them back into the incubator. After that, of course, it's clean from mites, right? We killed about 90% of the mites, but we still have these phoretic mites on the bees. Most of these phoretic mites in the next 12 days would also be in the sealed brood. And then what we do is repeat this treatment again after 14 days, 12 to 14 days. We treat these frames, and then our hives are pretty much as clean as could be. And we went and did this research on colonies. We did it here with wooden hives. This is very, very the most beginning part of our R&D process. So this was still wooden hives, and we saw that there's a very nice effect here. We were as effective as amitraz, so and significantly different than our negative control. I'm not going to go through the figures because I have a lot to show you. So we also saw that there's not a very bad damage for the bees. So it's what we saw in the frame level. It's effective for the mites and very safe for the bees. But we still have a lot to do, right? So what we want to do now is, it's nice that we could do it in the lab, but now we want to take it out to the field. So starting from a system that was very basic in our laboratory incubator, we started working on developing a heat chamber specifically to our needs, 1 frame per treatment, and that could be in the size that fits our robotic, that could go into our bee home. And this was a long process. This is how the heat chamber looks right now. This is of course set it in the bee home itself, but you would see shortly I'll show you how it's manipulated in the robot. So putting it in the, I'm taking you about a year later. We're already with the bee homes that have heat chambers. Our American field team is now located in North Dakota. North Dakota is a very intensive honey flow state. A lot of colonies travel, about 40% of the colonies in the states travel up to North Dakota, and that's where most of the honey in the states are produced. And you can see here the number of supers on the colonies. I think and this is me here standing, helping the beekeeper that is standing on a colony that has 6 supers on it. So this is a very intensive beekeeping, and this is where we started our field experiment. And you could see Ina and me. Ina also spent some time in Vicky's lab, and what we did here was the first attempt to do heat treatment robotically. So I'll show you this video. I did it in fast forward. So the robot comes to the hive, it picks up a frame. This is the frame that we already scanned. So we know that this is the right place for the sealed brood. We already did the scanning. So this is a sealed brood. It shook the bees off, and now it's taking it into the incubator, into the heat chamber, sorry. It's putting it in the heat chamber and closing the heat chamber for 90 minutes. And so this was our first attempt, and what we're doing here is very similar to what Paz that I showed you before. We're opening the cells and looking how many dead mites, how many living mites, and this was, and of course our control group was Amitraz, which, as Avner just said, is efficient only on the phoretic mites, only on the outside bees. If you use it again and again, it might affect the population, then you don't see. But most of the mites that we saw in Amitraz and without treatment were alive, and that's what we expected. And nicely, 99% of the mites that we treated in the heat chamber were dead. That's still frame level. It is robotic and it's a different product, but that was, but we're talking with beekeepers. They don't want to work with frame levels, and we felt that our machinery was already mature enough to start trying it with external researchers, that this could be published in scientific journals. So we started collaborating with the Auburn University. And the first thing we did, as the speakers before me said, we tried to look at it on the Tropilelax. Why is the Tropilelax so interesting? First of all, because all the beekeepers now worldwide are very much afraid of this new parasite. But the other interesting thing about Tropilelax is that it spends most of the time in the brood. The phoretic stage of the Tropilelax is probably very, very short. She doesn't need a few days walking around the colony and developing her ovaries. She could go directly into the brood. And as Nurit said, then she's hiding. Then in most cases, in most treatment, she's unreachable, right? So in this case, we have an advantage because our approach says this is not hiding. This is our trap. So this is a very efficient trap for a Tropilelax. So I'm not going to go through all of it, but Michael from our department and Ina, they went to Thailand and they tried to locate infested colonies of Tropilelax plus Varroa, and they had very good results, just as I showed you before from North Dakota. The Tropilelax is very sensitive to heat, and she also dies very, very clearly from this treatment. We continued with our collaboration with O'Brain.
Sorry, wrapping up, please, okay?
What?
Okay.
I didn't hear you, Tammy.
Sorry, I said you need to start wrapping up, please. We need to go
Okay.
to
Yeah.
the other.
Okay.
Thank you.
Okay, so again, with the Auburn University, we did a very big field experiment on the bee homes. I am not going to share the results because it's going to be published soon, but very similar to what we've seen before. And this early spring, we did again the experiment in California. We tried to look at the first brood cycle. This is based on a theory which was we saw that it works pretty nicely, that the first brood is working as a trap, and that was also very efficient. Again, very promising results here. Now, looking again at IPM approaches, we want to know that now we have a good treatment, but of course we want to monitor again. We want to be able to measure how infested our colony is, and if our treatment is working efficiently. And lately we've been developing this ability to detect mites by our cameras on the bees. So this is another project. It's just in the beginning, but we're also able to say how infested our colonies are. So to sum it up, with the focus on Varroa and maybe Tropilelax, our approach is very much to support the industry with real research and giving IPM solutions, meaning that we could monitor and respond by treating according to the situation of the colony. And that's it. I'm sorry I took a bit longer.
Okay, thank you. Thank you, Raya, so much. This bee home and the technology that you introduced is just really amazing. And hope that a lot of people here will continue with the contact and get more information from you for that. So thank you. Before we go to our next speaker, two things. First of all, I'd like to mention also that we have from Mexico participants as well, so worth mentioning. And I'm sorry, Hugh, before you do the share screen, I'd like to ask all of the participants who are here, if you can, if it's possible, to turn on your camera just for 1 minute so that we can do sort of a group photo of this event, if it's possible. I know some people are but if you can, and we will take a screenshot, and we'll have a group photo of all of us together here on this wonderful day. Hold on. Okay. Wow. So many people. Amazing. Amazing. Thank you. Great. Okay. Now, without further ado, our next speaker is Mr. Hugh Evans. He is head of the Bee Hero X, and he's going to tell us about Bee Hero and how we manage pollination solutions. So, Hugh, the floor is yours.
Can you hear me okay? And can you see my screen?
I can see your screen and I can hear you. I think maybe others as well. People say,
fantastic.
well, if you can. Okay.
Technical genius, you see. So my name's Hugh Evans. Thank you for inviting me to this this afternoon. I lead innovation at a company called Bee Hero. Bee Hero is
Hugh, wait a minute. Your mic was so.
Oh, can you see that now? Can you hear me now?
Yes.
Did you hear
Now we
anything?
can. Yes, and I'm sorry. I realized now that you're a doctor, Hugh.
It's not a problem. So I lead innovation at Bee
I
Hero.
I
Bee
apologize
Hero
sincerely.
is an Israeli company that was founded back in 2017. The founders are all talented people on their own. Yuval on the left is Israel's CrossFit champion, or was once. Omer on the right, the CEO, was a horse jumping champion of Israel. I think he set some record. And Itai in the middle, I understood his family was the Israel's largest beekeeper. beekeeping family, but I've heard of another one now in this meeting. So I'd certainly say Boaz's father's the nicest beekeeper I've ever met, and possibly the most charismatic as well. So while they're individually talented, when they got together, there was synergy between them, and this resulted in Bee Hero now being the world's largest pollination service provider. Oh, so Bureau technology lives inside the hive. It's a little electronic gizmo that lives inside the hive and monitors various things, offering insights into the bee health, the bee strength, bees' activity, and things like that. Obviously, it's obvious to a beekeeper if he can find out what's going on in his beehive without having to open it. It's IoT technology, meaning you can access all this data remotely. So it makes complete sense if you're picture yourself as a large American commercial beekeeper with tens of thousands of hives spread out across America. If from the comfort of your desk, you can look at all your bee yards and see what percentage of hives have problems, see how strong they are. This obviously helps with logistics, deciding where to send the van of guys next, but also it allows you to predict what resource you'll have to offer pollination further down the road. Not only do the beekeepers benefit, but the growers that we bring hives to get a much higher level of transparency to actually the health of the colonies and how strong they are, which is reassuring for them. As we've spoken about temperature, temperature in beehives, bees thermoregulate the brood, and so there's a lot you can tell. There are many insights you can gain about temperature within a beehive, and the temperature is very easy to interpret. What I mean by that is I can take the temperature of my children and tell a lot about their health, even though I'm not a doctor of medicine. But also, we look at the sounds inside the hive. If you can imagine between 40 to 60,000 bees inside a beehive, this throbbing ball of brood, if you like, we can interpret the nature of that throb. Now, the throb is very much like a heartbeat of a human in that it's an incidental noise the colony happens to be making when it's heating up, processing nectar, doing all sorts of things. And very much like a heartbeat, it's very difficult to interpret. So I could listen to the heartbeat of my children all day and I'd have very little insight into their health because I'm not a cardiologist. And in a similar way, to detect the subtle changes in the throb of the bee colony takes a large quantity of very clever Israeli data scientists all in an office in Tel Aviv. It also takes AI, machine learning, stuff like that. But also, because there's a lot of variability between bee colonies, it takes data, big data, data from hundreds of thousands of bee colonies in different parts of the world. And really, it's the size of the data set that Bee Hero collects that gives it most value and gives its accuracy its insights the best accuracy. Not only do we monitor beehives, we monitor the crops that we bring the beehives to pollinate. So we have little in-field sensors to sense the distribution of the pollinators through a crop. This is a field just above the Sea of Galilee, which is the first place we tried our little sensors. And using acoustics, we can hear the bees flies past them, which allows us to sense the density of pollinators in different parts of the field and how uniform that is. In this same field, to these growers, seed producers, they were very keen to know how many bees are in the field. So before using this technology, people came to count the bees. They'd come, I think it was every Wednesday morning, it doesn't really matter when, and they'd stand there for a few minutes in different parts of the field, and maybe for an hour or so, and then that gave them a count. Our system looks for bees about 4 times every second throughout the day and night of every day for as many weeks as you like. So you can understand the resolution of our technology. Also, our little sensors can be dotted all over the field while looking all the time. So it's easy to appreciate what the technology brings to that party. As they continued doing their manual counts, this did enable us to correlate what our sensors thought were flying around the field and what the human beings saw flying around the field. And we saw a very strong correlation, should I say. This is the genuine data from that first trial performed all those years ago. I think we call it the PIP system, also won a Time magazine Best Innovation Award a year or so ago. Nowadays, we use that system in all different crops in all different parts of the world. Probably the most valuable part of the system is it allows us to make real-time adjustments to our pollination, a real-time response. So here is an example on the Pollination Insights platform. Here we have a field. We dump some bees in the top corner. We can see at these sensing points that, wow, we have okay sort of bee density up here. It's sort of okay down here. But by the time you get all the way over here, there's not quite as many bees as we'd like there to be. But the beautiful thing is we see this the day we drop off the bees. So a day or two later, we'd make another hive drop down in this corner. And later that day, we can see straight away that now we have uniform bees across the whole field. So the real value is being able to react in time to fix the problem before the problem actually arises. Not only do we monitor honeybees flying around onion fields and all other fields, we looked at bumblebees flying around tomato greenhouses. Now, I did this down in Kerem Shalom. I don't really know how to pronounce that. It's very close to the Egyptian border. There was a lot of sand and camels, I seem to remember, in that region. And yeah, so we could also monitor the distribution of bumblebees as they pollinated their tomatoes. Of course, now we're looking at things beyond honeybees. Now we're looking generally monitoring things that fly around. We fit sensors in apple orchards on the East Coast and the West Coast, actually, of the United States. We can then leave those sensors in and keep listening for pests. Stink bugs are a big problem. Now we can hear those. Now at the moment, apple orchard owners, by law, they're restricted to how much pesticide they can use and also how often they can use it. So to treat pests, it's a very simple schedule. They use as much pesticide as they're legally allowed to, as often as they're legally allowed to, which does quite good at keeping rid of the pest, but could also be using a shotgun to kill a sparrow. By monitoring the actual pest levels in the different parts of the orchard, this allows people to use insecticides far more sensibly. We've already heard about the problems that insecticides bring to crops. Something else we've heard about are Asian hornets. Now, as a European beekeeper, I can tell you that some French beekeepers in particular might rate Asian hornets as being worse than Varroa. I'm not exactly sure if that's the case, but 2 years ago, I took this picture of an Asian hornet, and this was outside my front door. Now, we manage about 50 colonies. It's a bit of a research apiary. We spend most of our time doing crazy bee experiments. And yeah, so now we have the Asian hornets almost. Now, I took these videos. I don't know how well these are going to play. These are fantastic videos. I'm certainly happy to share them. So with the organizers, but basically the Asian hornets hover outside beehives, hawking it's called, and they catch bees that either come or leaving the hive. We bought a very expensive camera to do this investigation. We need to understand what the hornets do most. Expensive camera, expensive lens, expensive tripod. And in the end, we did all of this recording with our iPhones. Here you can see the hornets attacking each other. And now you see a bee almost fly into the hornet's legs. So yeah, Asian hornets are a real problem. We trained our system to detect Asian hornets. These are Vespa velutina. This is quite important because if you can catch them coming into your apiary, if you can catch those first scouts, there aren't many nests in your area, and it's quite easy to eradicate the problem. The problem is once they're established, it gets very difficult to get rid of. Now, beekeepers aren't actually at their apiary very often. They tend to visit it for a few hours once a week. So for this reason, the chance of them actually spotting a scout is very small. But if we've got 24/7 monitoring at the apiary and we can send an email alert to a beekeeper to say, you've got scout hornets in your apiary, then this is a very useful tool. Up in Washington State in America, the USDA, we did a project with the USDA that got the Vespa mandarinia, the larger cousin probably of the Vespa velutina, and we managed to put one of our acoustic monitors in front of the nest entrance, and we monitored. We got thousands of acoustic recordings, which allowed us to make quite a robust acoustic signature of the hornets. Not only could we see the daily flight profile from the nest, we could actually see the difference in size. There's a slight difference in signature depending on the size, so we could also see the demograph of the nest. Okay, so we look for hornets, we chase bumblebees around greenhouses. It was not that long ago. I came out of the Peruvian rainforest seeking the wild pollinators of vanilla. But most effort, research, and innovation is focused on optimizing hives for pollination of almonds in the Central Valley of California and more recently Australia. This is a huge business. I believe 80% of the world's almonds comes from the Central Valley of California. To pollinate all these almonds, they need to take a lot of bees. I think it's almost 2.7 million hives are transported to the almonds just for 3 weeks every February. So I guess part of my job is to think, well, how can we make that easier? So what if we took half as many hives that were twice as strong? Same number of bees, but half as many truck trips. Would that actually work? So what I mean by that is, say here we have two six-frame colonies and they produce, in this example, for the sake of the presentation, a jar of honey, but we're actually talking about a jar of productivity or a certain number of pollination flights. If we turn those two six-frame colonies into one 12-frame colony, do we get the same performance? Do we get the same number of pollination trips? And it turns out that you actually get more. What happens is there is a benefit of scale, and bees prefer being in bigger colonies and they work harder as a result. So you make more than just a jar of productivity. What I mean by that, let me be clear. There's two six-frame hives. If you take one frame of bees from one of these six-frame hives and you move that into a 12-frame hive, that same frame of bees will do 50% more work. They just enjoy being in a larger colony. Well, to be honest, this isn't our innovation. There's about 100 years of research almost that agrees with this, and it does believe there's a 50% increase. But we've done this year on year. We've done this in different crops. We've done it in the Mediterranean climate of California and also in the Mediterranean climate of the Mediterranean here in Italy. And we do see a 50% increase in performance using fewer, stronger hives. Indeed, it's almost 100%, almost doubles the performance of the hives. We published that along with the USDA, who we did some of the experimentation with. If anybody wants to read more about that, all results were statistically significant. Pretty big study that, actually. That was just published a few months ago. Okay, so now we've decided how many bees hives we can bring to the orchards. Now it's a question of where's the best place to put them. A beekeeper would prefer just to put a big load of hives next to a busy road as he drives up there. But that you can space them around the orchard in different ways. But this next experiment, we were actually wondering what effect the orientation of the hive had on the bees. So here's a pallet of bees. Half the bee hives, two of them are facing east to catch the morning sun. The other half are facing west. Now it gets cold at night in the orchards. It's still I still think of it as winter, February. So one would expect the hive facing east that gets that morning sun warming up the front of the colony, that sunshine pouring through the entrance, those bees would start flying sooner than their west facing counterparts. Of course, at the end of the day, the sun is left shining on the west facing hives, but you wouldn't actually expect them to stop flying much later because by now everything's warm, the ground's warm, the air temperature's warm, so you'd expect them to stop flying at a similar time. And indeed, this is exactly what we saw. We saw about, if on average, all the hives pointing east started flying about 44 minutes sooner than the hives facing west. When it came to stop flying, it was kind of about the same on both, as we would expect. So this is quite an interesting insight. 45 minutes of pollination is quite a long time if it can simply be achieved by the orientation of a hive. But unfortunately, managing the orientation of that hive is not a simple process. You get somebody turns up in the middle of the night with a lorry load of bees. He's got to plonk them down. You're usually lucky if you can even find the apiary. If you then give him a compass and tell him which way he'd like them pointing, there's very little chance he'll achieve that correctly. But then we delved deeper into the data and we actually split the colonies into a group of strong and a group of weak. So would our fewer, stronger hives benefit? And the answer is yes. Strong hives don't really care which way they're pointing. They're very good at generating their own heat. It's the weak hives facing in the wrong direction. So the weak hives facing west can take up to 2 hours to start flying faster. So start flying in the day. So that's quite a big effect. But you obviously using fewer, stronger hives removes the problem of orientation. We published that actually, it was a year or so ago now, again with the in conjunction with the USDA. If anybody wants to read more about that, go read that. So what does this actually mean for pollination of almonds? Okay, almost 3 million hives are currently brought there. If we took half as many hives, twice as strong, one could argue just over a million hives, 1.3 million hives is all you'd have to take, which would be half as many truck trips. But when you factor in the optimization that comes with taking stronger hives and the benefits and the eradication of the orientation problem, it actually is less than 1 million hives you need to take. Now, that's actually a third of the hives we take today, which is a significant difference. And it just goes to show what Israeli-led technology can do, can bring to pollination. That's what I call precision pollination. So that pretty much concludes my talk. And if there's time for questions, I can do them, or maybe I should stop sharing and let the host continue.
Excellent, excellent. Thank you so much. It was so interesting. I mean, really, I thought pollination, but so many factors that affect it and so much interesting research being done. Amazing. Okay, so thank you, Dr. Hugh Evans. We don't have time for questions right now, but what we're going to do is we're going to go to our last speaker today. And as soon as our last speaker finishes, then those who need to leave will leave. We will take some questions. And for the experts who cannot stay with us, I will send you some of the questions that pertain to your activities, and then you can correspond directly with the asker. Okay, so let's go to our final presentation for today. And I'm very happy to introduce to you Ms. Amalia Eshed. She is the CEO of H4Bees, and they have a scalable solution to support bee health and pollination with a very interesting nutrition solution. Amalia, the floor is yours. Amalia, are you with us? Presentation, but we cannot hear you.
Can you hear me now?
Yes, now we can hear you. Excellent. We see
Yes.
your presentation as well. Yes.
Okay, perfect. Okay, but I'm trying to, it's not the first slide. Let me just try. I don't know why it's not. Okay, okay. Okay, so thank you, Tammy, for this invitation, and thank you for this fascinating lecture. For someone who's being the last one, you have one advantage. You already know what I'm not going to repeat. So let me jump straight to the question that matters. How do beekeepers produce more honey and stronger hive next season with what they already have? Bees, hives, and the need to make a living. So I'm Amalia, and I'm the CEO of H4Bees, and our biggest challenge is the food chain security. We have developed a proprietary feed supplement for bees. The product is commercial for the first year in Israel, and we are finalizing a very happy and successful season in Israel with 24 very happy customers. So we are all aware to the challenge, as I just want to mention the other side of this picture, a rising global demand for premium and organic honey, and the real potential to differentiate, to produce honey that commands a better price. In Kenya, for example, domestic demand for honey is much higher than the local production. So what is our solution? What is our products? We are talking about a feed supplement for bees. It comes in a version of gel or powder. It can fit Western beehive and top bar, and you apply just 5 grams at the entrance of a beehive with no need to open it, which is a great advantage, of course. It strengthens bees and increases their resilience to different stressors by boosting their natural defense mechanism. When the system is stronger, bees can resist better pathogens, pesticides, heat, cold. They stay active longer, produce more honey, and increase pollination. By the end, what we usually see is an increase in total yield of honey and different crops like almond, apple, blueberries, and avocado. The ingredients are entirely natural. There are organic elements, mineral, and pheromone, no chemical, no caffeine, no antibiotics, and no residue in the honey. It is HACCP compliant. It is licensed by the Israeli Ministry of Agriculture. It is FDA registered, Vietnamic registration, and the ingredients are all GRAS, which means generally regarded as safe. In the next slide, you will see a video and you will be able to see how bees react to the product, react to the application of the product. So we begin with, okay. So this is pre-applying the product. You can see it is quite a strong hive, and you will be able to see the application and the reaction, the increase in activity after the application of the product. Okay, so now let me show you what this looks like, in practice. So there are here 3 different pilots, 3 different territories, all completed in 2025, different crops. So I will start with Ethiopia, working with Jimma University, one of the world's leading coffee research institute. Treated hive produce 100% increase in honey yield and 23% increase in coffee yield. In Ghana, we partner with the National Beekeepers Organization, and we prove an increase of 60% in honey yield and 22% in cashew yield. Cashew yield in this trial orchard, as I said, it was 22%. The trial ran from December 24 to April 25 in commercial cashew orchard in the Bono East and Oti region. And the last one in the United States at Washington State University, colony grow rate increased by 43% in our treated group, meaning stronger, larger colony during difficult period of blueberry pollination in the United States. This study conducted with Professor Lisa De Viter and has been, and I'm very happy to say that it has been accepted to publication in one of the important entomology journal in the US. So the pattern is consistent across very different climate, crops, and beekeeping system. And of course, we have much more result from trials in Israel and other territories, but I wanted to focus on Africa. And I would like to show you some more video regarding the Ethiopian coffee pilot. So from the left side, you will be able to see an untreated hive, and from the right side, a treated hive, 48 days after the end of the blooming season, you would normally expect hive activity to drop significantly. We analyzed here video footage of the hive entrances. Treated hives showed 75% higher forager bees activity comparing to the untreated. That means the colony is still functioning, still foraging, still building strength. Weeks after untreated hive have essentially become much less active. And for the next video, you will be able to see here when we opened the hive at the same trial in Ethiopia, the result was visual and immediate. The super of the untreated hive was empty. The treated hive super was full. We had this trial together with partnering with Professor Gezagen Beracha from the university, from Jima University. And some video from the Ghana trial. You will be able to see here from the left side, the untreated group, and from the right side, the treated one. You can see the result I already mentioned. And we have testimonial from Richard Okoye, which is the founder and the president of Ghana's National Beekeeper Association. And one of them was bees were more active and survive better under stress with the H4Bees product. And this brings me, okay, so this is his testimonial. And this brings me to something, I would say, especially meaningful for today, which is our upcoming project in Kenya with Mashav, led by Eitan Chatzor, Mashav expert in agricultural development. So we are going to have to work with large producer and also small-scale beekeeper, training seminar for direct partner and wider beekeepers community, mainly women and youth. And honestly, I would like to say that the bees surprised us in Africa, in Ethiopia, in Ghana, stronger colony and more honey in condition we had never tested. That's what we are bringing to Kenya, and we are looking forward to work together. So thank you very much. And if you have any question, we'll be happy to answer.
Hey, thank you so much, Amalia. So interesting. And I think we got a pretty well-rounded range of solutions for beekeeping and for improving the hive strength and health today. So we have really just maybe 2 minutes for some questions. If you have any questions, please put them on the chat. Write them out on the chat, and I will give them to our experts. Let me see. Some people already did put there. Let's see. Okay, so let's just say already, Marco asked, being that the harmful insects damaging the bees, would it be proper to work on the varroa or beetles pheromone by creating traps, like pheromone traps, with reduced entrances within the hive?
Who do you address this question to?
Please, any of the experts who are present here who think that they have something to say about pheromone traps.
I can do that. I mean, is Nurit there? If Nurit is not there, I can take it.
Nurit, she's gone. She might rejoin, but she's not here at the moment.
So I can say that up to now, we don't have any possibility to change varroa behavior with pheromones. Maybe in the future, reducing the entrance would not help. So, I mean, did I answer it all?
Not possible. Yeah, that's an answer. Okay.
Yeah, but you know, we are doing a lot of work on, I think in general, on semiochemicals, how they can be used in the management, successful management of honeybee colonies.
Thank you. We have a question from the Embassy of Israel in Rwanda. Health feeding system of bees means a health ecosystem, food security, and biodiversity. What can you say about the integration of bees with native floral species that are rich with antioxidant oxidation for bees? Because here in Rwanda, vegetation cover of bee-friendly flowers is disappearing, thus leading to starvation of bees. Is there any research and recommendations about the rehabilitation of these indigenous plant species in favor of bees?
I can suggest them to consult with my colleague Beatriz Naganso from ICIPI. She is doing a lot of work about these plants and pollen, you know, and honeybee health, and so maybe she can help with some suggestions in African conditions. Because we in Israel, for instance, planted a lot of eucalyptuses, and we support planting other plants, bee-friendly plants.
Okay, thank you. Wow, this is for you, Vicky. When you talked about absconding reasons of the colony collapse, does that include environmental impacts that might not be measured? Are there things that you didn't measure? And about the virus, when they are asymptomatic, can they harm the colony? And what kind of stress can activate them?
So when the bees are, this is one of the very big problems, that we don't see the symptoms. The deformed wing virus, we see deformed wings. When we have acute paralysis, we have acute paralysis, we see paralysis. But when we don't see paralysis, it doesn't mean that the virus is not, some of the viruses are not there. So, I mean, I would say Happy Bee would probably be able, to suppress viruses. And when I'm saying Happy Bee, of course, I'm not meaning that they will be happy mentally. I mean that they will have enough forage and they will not encounter pesticides. That will enable them, because I don't think we can totally prevent the viruses. We can try to do our level best to prevent any importation. And I think this is a very important thing that I should tell. People often think, beekeepers often think, and even it can be on the level of the governments, that they don't understand that the local bee is the best bee for the place, because they already adapted to the local conditions. So you can work and try to breed the best out of what you have, but you should not bring something from somewhere else, because we do not know what problems we bring with these other bees. It looks that these bees makes a lot of honey, let's say in Germany, and it's calm and nice. So why don't we bring a bee from Germany to Africa? In Africa, the bees are more aggressive. It's difficult to work with them. And in Germany, you can work without any bee suit. But it's a wrong idea, because first of all, the bees from Germany or other places, they would not be adapted. So they will be more sensitive to environmental conditions. And not only they will bring you new diseases that you are not familiar with. and the bees, and that will also infect your local bees and endanger the whole operation. So I think that's, a very important message that I would like to convey. And if you want to help bees, also vegetation, you should think about often the water is very important for the vegetation and also for bees. Bees need water to cool their colonies and also to liquefy their already mature honey to be able to consume it. So I think the water availability and good water quality for the bees is also very important. And sometimes it's very difficult to provide it under African conditions. So this is something also important to consider.
Okay, thank you. I'd like to point out here that if you look on the chat, you will find some very interesting exchanges. We have with us, hold on a second, I just lost her. Okay, we have here also Tatiana Vasilkivska. She is the chair of the NGO All Ukrainian Brotherhood of Beekeepers, the vice president of the European Beekeeping Association, president of the Apimonia Congress, founder of Help on Bee Wings Charity Foundation, and she has put her contact information here. So anyone here who is interested in contacting her and as part of the fraternity and the sorority of beekeepers of the world. So I'm just pointing that out. She has put her contact information here as well. Also, I've put Dr. Victoria Soroko's contact information and also Dr. Nurit Eliash. And you have also all of the companies that have presented it today. They have websites. You could just Google them and get in touch with them. They will be very, very happy to hear from you. I also want to know if I saw here that we had a Memis amongst us. Is he still here? It's already gone. Okay, I just want to point out that we have here, and we have with us also someone that I would like to mention, and I hope he's still here with us. It's Chaim Efrat. Chaim, can you point yourself out, please, and say hello? He is also one of the leaders of the Israeli beekeeping, formerly the head of the beekeeping extension services. So hello, Chaim, and thank you also for being here with us today. In fact, there are many very distinguished people, and now we are going to end our session. And thank you all. Thank you to all of the speakers, and thank you to all of the attendees being with us today on this occasion. We are very, very pleased to have been with you. I hope that you found it very interesting and fruitful, and we hope to see you on our future webinars and events as well. So thank you so much to everybody, and we'll see you next time. Thank you.